Hey everyone, this is Jim Armstrong with Snyk. I am Senior Director of Product Marketing here for our container and infrastructure as code products. I want to send a special welcome to everybody who's joining us from Kubecon. If you are at Kubecon, I hope you're having a great time and learning a ton of new and exciting things at Kubecon. Always a great show, even virtual. And so hopefully folks are having a good time there. If you're not at Kubecon, that's fine too. You're still in the right place. This is not specific only to Kubecon attendees, so we welcome you as well. Today, what I want to cover in the next 30 minutes is a bit of information about a Snyk report that we ran recently called the Infrastructure as Code Security Insights Report. So we have a couple of new reports from Snyk that have just been released recently. This week, we released one called the State of Cloud Native Application Security. That was a bigger and more extensive report that we've released, and so that one's really exciting. You can find that one published on the Snyk website, and you'll find it in our KubeCon booth if you happen to be there as well. The other one we released slightly before that was one that was very specific to infrastructure as code. We talked to a number of customers. We actually did some surveys, not just of Snyk customers, but to users of IAC in general, to find out how they're using infrastructure as code. And really the goal of this survey was to understand how people are treating their infrastructure as code. We find a number of folks who are still fairly new to infrastructure as code. Everybody, it seems, has some form of it, whether that's Terraform or Kubernetes or CloudFormation or something. There seems to be pockets of it just about everywhere. And of course, we're seeing some shifts in how people are using it. We're still seeing a lot of people who are trying to figure out how they use it and who is going to use it. As we think about how applications in general are shifting, we're finding that developers are responsible for far more than they used to be responsible for. And that includes things like infrastructure these days when people are using infrastructure as code. Kubernetes in containers are one of those weird ones that, there's some things that are very infrastructure-like in those tools, in those systems and platforms. There's some things that are very application-like in those platforms, and so that's an interesting place where it kind of hands off from developers to operators and to other folks. And the cloud, of course, can be part of that as well. How you actually set up the cloud to run Kubernetes or set up the cloud to run your applications. So we're seeing this shift, and we wanted to find out how our customers are dealing with infrastructure as code. Are they treating it like other forms of code to keep it secure? Or are they still doing things kind of in a traditional infrastructure way, even though they are using infrastructure as code these days? So that's what this report covered, and that's what we'll go over today. For the folks that are here, I hope that everybody's familiar with what infrastructure as code is. If not, certainly there's loads of materials out there to learn about it and to play around with it. And we'll sort of explore this as we go through it a little bit as well. But the big thing about infrastructure as code from a risk standpoint is it does open up some new potential risks inside an organization. It's easy now, of course, to deploy infrastructure, as often as you change your code, as often as you commit code and it goes through your pipelines, you could change your infrastructure right along with that. And if somebody is doing things the wrong way and you don't have the appropriate controls in place, then you can, of course, just continue to push out misconfigured resources, which might allow somebody into your environment. And so it can be a big problem. The other flip side of that is you could put up all kinds of gates and walls and obstacles and make sure that nothing gets through without being thoroughly checked. But if you do that the wrong way, then you lose some of the advantages of infrastructure as code, and that you can't move as fast as you might want to move. And so it's a bit of a trade-off, or at least seems that way. Now, this workflow is not probably completely unusual, I think, to people. This is a typical pipeline that we see people's code go through, or we see containers go through. And so the fairly familiar sort of workflow where you code things, you build and test those things through various iterations, and then it goes through some sort of release cycle, hopefully mostly automated through that release cycle into your let's call them production environments. They may be various levels of production that you have in your organization, but some level of running and being live for people to use. That's not unusual. Infrastructure as code adds some new complexities here, some new linkages here into this, or at least it potentially can. We don't see everybody doing all these things, right? So we still see people treating infrastructure as code much like they would treat scripts in the old days, where it just sort of sits locally on a person's machine and they can run it when they want, but there's no sort of centralized control over it. This represents more of a centralized control where you're treating infrastructure as code really as code, and you're treating it like you are a developer. And we're seeing in some cases kind of a new class of developer arising with this as well. It may be infrastructure engineers who are becoming developers. They may be part-time developers. We're seeing a lot of that as well. But nonetheless, this represents that ability to completely automate everything in your infrastructure as code as well. All right, so let's talk a little bit more about the report here. So again, as I said, we interviewed and surveyed a number of folks for this report. There were over 500 respondees. Most were, in fact, not Snyk customers. We ran this report or this survey via a third party who contacted their own database, so it wasn't just Snyk's database. We had a mix of respondents. So we had respondents in smaller organizations, we had respondents all the way up to very large organizations, and across a number of roles in their company. And I think it sort of highlights, who is using infrastructure as code. It's pretty much every organization of all sizes. They, like I said, it's touching everybody. But I think the actual personas of the users and the people that are involved in some way in infrastructure as code, I think is really interesting as well. It can be developers, it can be infrastructure teams, it can be security, it can be a number of folks in an organization who are impacted and users of infrastructure as code. So I'm going to do a couple polls as we go through this presentation because I want to get some of your feedback as well. And so I've got a, if I can find it here, got a poll that I'm going to kick off. And so the first question here is what infrastructure as code technologies you might be using today, and you can select multiple. Obviously, there's a lot of people who are using more than one technology, and that's perfectly normal and perfectly acceptable. I'll show you kind of how the survey went that we ran. That's in the Security Insights report here in just a second, as we gather a few responses. All right. Excellent. So let me share what I see here. So as you can see, from the audience today, this is your own responses today. We have a mix, right, of people using loads of different things. Kubernetes and Terraform at the top here. Not surprising, since I suspect a number of you are from Kubecon. But Kubernetes is extremely popular as well. Not everybody considers Kubernetes a form of infrastructure as code. I do, because you're configuring an application using APIs and using using declarative syntax. So to me, it's infrastructure as code. We consider it infrastructure as code at Snyk. But Terraform, CloudFormation, obviously, and various cloud tools that are specific to your choice of clouds are there. And there's tons of others. Go to meeting, go to webinar will only let me put in 5 responses, but this list could go on for pages if we really wanted to list out all of those options. All right, in the poll that we ran, we found a lot of people using very cloud-specific tools. So CloudFormation as a resource manager, Kubernetes was way up there as well, and so those were really popular. Terraform was a little further down the list, but we did see. So we asked a second question, which was, what are people planning to use in the future? And Terraform was much higher up there. So I suspect there's loads of Terraform usage out there. It's maybe not as formalized as people might want it in order to be clicked on here. Anyway, we did get a wide range of responses. So that's very common. And again, very common to see multiple formats within an organization, people using CloudFormation and Terraform, which may seem like a conflicting goal. In some cases, maybe it is. In some cases, you just have different teams and different parts of the organization that chose different paths. Kubernetes obviously can live with a lot of these things. So the next question we asked folks is, who holds the primary responsibility for securing infrastructure as code today? And then we followed that up with, who should hold responsibility for infrastructure as code security? So the idea there is that potentially the people that are responsible for it today are not the people that ideally you would want to be responsible for it. So that brings me to my next question for all of you, which is, in your opinion, again, who is responsible today might be slightly different, but who should be responsible for this? And you've got really sort of three large buckets, I get that, of responses here without getting into very specific titles. But generally speaking, is it app teams? Is it the actual developers themselves? And again, this is just primary responsibility. I know a lot of you, if I put this as a multiple choice, a lot of you would probably choose all three, and there is a yes, all of the above option here. But should it primarily be your app teams, your developers, the people who are sort of writing the apps themselves? Is it security? Should security be the ones that implement the checks and that actually carry out responsibility for changing things to make them secure? Is it infrastructure? And again, infrastructure is one of those that you may be an infrastructure engineer by day and a part-time coder by night as you write your infrastructure as code. But curious how people sort of see this. We had some interesting responses to this one in the IAC survey. We also had an interesting response to this in the Cloud Native Application Security survey. So I'm going to close this and we'll show you the results here. So a lot of people, as I suspected, would choose all of the above. It's a team responsibility, right? It's everybody, and it kind of depends too on the type of infrastructure as code you're using. If it's Kubernetes and we're talking about deploying applications or deploying the workloads, that seems much closer to the developers. If we're talking about Terraform or CloudFormation and we're specifically rolling out infrastructure and storage and things like that, then it seems a little closer to an infrastructure person. But those folks, I think, are very closely aligned or getting much closer to each other. The interesting thing that we found in the state of cloud native application security poll, and we don't really have the ability in the GoToWebinar to kind of get into this level of detail, but what we found is developers, when they took this, very similar question, when they took this survey, were much more likely to rate themselves as being primarily responsible than security engineers were. So security engineers really didn't think the developers were quite capable or quite ready, I guess I should say, of handling the security for not just infrastructure as code, but other aspects of cloud native app security too. It could be containers or serverless or other things. And there are a number of reasons why that might be. That'll come up here again in a couple of seconds. So in our survey, we found, again, very common for people to say it's a shared responsibility, and I think that's spot on. As much as there's a right or wrong answer to this, I think shared responsibility is a very right answer. It needs to belong to everyone, and not individually, but collectively as well. We'll talk a little bit about what we do at Snyk towards the end of this webinar, because I think that's a good sort of model for others as well. In terms of who should be responsible, the answers changed a little bit more towards developers. Now, I lumped developers and DevOps together in this response, and we took out the ability to say it's a shared responsibility, and we asked who should be responsible. So if you could only pick one, most people sort of leaned towards that developer or DevOps type personality. And I think DevOps there is sort of that it's a shared responsibility thing, because DevOps tends in most places, it's not really a title, it's sort of a process that denotes that it's shared amongst various teams. And then the next question then was, okay, so, you know, whoever's responsible for it, how are you actually doing infrastructure as code security? And, you know, one of the ways you could do that obviously is by including IAC tests in your pipelines and doing it all automated or mostly automated, or at least starting with it being automated if you know, potentially you're doing it in a bunch of other places. So I'd like to see from all of you how you're doing this. If you're using automated tests for your infrastructure as code, how often are you doing that? Is it in every pipeline, at least the ones that you're aware of and know of and have some visibility into, or is it less than that? Or is it not at all yet? That's something that is more common than you might think, as you'll see here in the survey responses that we got. Yeah, I'm seeing a lot of responses leaning that way now, in fact, as well, right? So looking at these responses, again, a lot of people who, even amongst this crowd, are not doing this yet. And again, that's not uncommon. It was a little bit surprising to me, I think, when we ran this survey to find the number of folks who were saying that they aren't quite doing this yet. And there's several other ways that people can be doing this. I'll show you those as well. We do see a mix of other things. Nobody, at least in the time that I gave you to actually click on a response, nobody clicked on the every pipeline, every time response. I think that's a goal for a lot of folks, but it's not quite there yet. And again, it points to the fact that I think for a number of organizations, infrastructure as code is still a developing sort of practice inside their organization. In the survey that we ran, the numbers weren't totally different. Slightly fewer that said they're doing no testing of their infrastructure as code in their pipelines. But again, it was a much bigger audience, so not completely unusual that they would differ a little bit. But very few, only 24%, said they were always doing infrastructure as code tests in their CI pipeline. And in fact, I'll show you as we get to the end of this too, there were very few people who said they were doing infrastructure as code to the best of, you know, sort of industry practices. And so that was a bit surprising to me as well. I'll show you what that number looks like here at the end. I do think, as I said, I think it's a goal. I think people want to do this. I think the tools are coming along, and I obviously have a bias here because Snyk has a product that does this very thing. I'll show you that a little bit towards the end here as well. But I think it's a goal. I think people want to be able to test these things in their pipelines. I think they want to make sure every time there is a change to anything, and anytime something's being deployed, it's being tested. I think they want to, you know, even get to the point where they're continuously testing things to make sure it continues to stay, you know, secure as time goes on and things don't drift from what they're supposed to be. So we also asked folks what's preventing them from including security tests in their pipelines. And you know, the answers here, again, this was another one where people could choose multiple. I didn't create a poll for this one because it's one that, you know, kind of takes a bit of thought and a bit of time to sort of work through a little bit. But as you can see, what we generally see here, the biggest things are there's no real standards, at least within an organization. Now, there are benchmarks. There are things like CIS. You know, each cloud sort of has their own best practices. AWS has well-architected frameworks and things like that. Every cloud sort of has its own set of benchmarks. But what we find with those benchmarks is they're okay as a starting place. If you look at CIS, for instance, it's not a bad starting place. But if you look at the AWS benchmark from CIS, it only covers a very small number of AWS services. Last time I looked, I think it was 7 AWS services that were covered. And AWS obviously has hundreds and hundreds of services. So the benchmarks sort of help, but they don't get you very far. And I think that was a big problem that people had, is they don't really know quite what to test. Every team is sort of out there making their own decisions about what to test. And then there's some responses around, you know, tooling and those kinds of things as well that cause some issues. But that idea of not having an idea, a clear set of things to test against, I think is a big problem. And that's one that I think a tool can help with, because a tool like Snyk will come with a preloaded set of configuration checks and rules and policies. But again, it's one of those that I think is an evolving area in the industry as a whole. So the next question I have for all of you is, how do you find out about misconfiguration issues? So, if the first question, the last question we asked was, how often you're doing these checks in your pipelines. The next question is, aside from your pipelines, or maybe including your pipelines, if you are doing that, doing those checks there, how do you find out about misconfigurations? If somebody is deploying something that isn't quite right or isn't quite up to your specifications, how do you find out about it? And again, we're sort of limited in the number of responses. I realize there are a bunch of other ways you could potentially find out about this. So sort of generalize your responses and try and get them to fit into one of these buckets. I think these first two, really the first three, you think about are kind of post-deployment methods of finding things that are wrong. The first two, are proactive. The third one, obviously, very reactive. Hopefully that's not the only way. I realize it's probably common for almost everybody to find things out that way, but hopefully it's not the only way. Manual code reviews are another that I think are kind of interesting in that they're helpful. Here's what all of you said, by the way. They are helpful, and we see a lot of folks here are doing manual code reviews. But if you're changing things as fast as you're changing code, manual code reviews can be a challenge as well, right? So we see things, and this could include things like pair programming and those sorts of concepts where you're doing it in a more sort of proactive way, and so it certainly can help. And it's not saying that it's a bad practice, but again, it's one of those things where humans can make mistakes. We do see a number of people who are finding things out after they happen. Again, that's not unusual. It doesn't really matter whether you're doing testing in your pipelines or manual code reviews and things before you deploy, or if you're doing pen testing and audits afterwards. Some things are going to get caught when there's an incident, and it seems at least to be an unavoidable thing for now. Hopefully we can make it more avoidable by improving the state of infrastructure as code security. Again, in our surveys here, very similar kind of responses, right? We see a lot that are doing sort of those post-deployment checks. Again, I think part of that comes from the way that infrastructure is tested today, right? That's how we do it. We set up infrastructure, and of course, if you're doing this in sort of the pre-infrastructure as code days, you have time. You can set up, test infrastructure. You can test all that before it's really sort of live, and the changes are much slower. So doing those kinds of tests either ahead of time or after things are deployed certainly can be helpful. With the infrastructure as code, these things still go on, and they should continue to go on. We want to know exactly what's running. Things can change in the production environment that aren't reflected in the code, and so I don't think the types of testing that are post-deployment will go away altogether, and I'm not suggesting that they should go away altogether. I think there's certainly an important component of what's out there. Drift detection is a real thing and a real capability that people want to have. Knowing what's running versus what's in the code that says is supposed to be running is really important, and people want to know about that as well. We see loads of people doing manual code scans, and again, as sort of reflected earlier, the infrastructure testing, IAC testing in an automated fashion is also is a little bit lower than the others. And again, that investigating incidents, that one's always scary, right? Nobody wants to be in there and be sort of, I showed a slide earlier that had Capital One. I don't mean to pick on Capital One. They're probably in a lot of people's presentations, but we see that in a lot of places. These incidents still happen, but it is scary, right? Hopefully we can reduce that number dramatically through some of these automated testing and other tools. And so the final question I have for you as part of my survey is, how confident are you that you or your organization in general can find and fix a misconfiguration problem in less than one day? And this could include finding them before you deploy them, right? So if you're doing the manual code reviews, or if you are doing some checks in your pipelines, which very few people are, but at least here today. But if no matter how you're doing your checks, how confident are you that you could find those and fix those within a day? And within a day of actually deploying that infrastructure. So you have sort of narrowing that gap between the time something is live and people can get to it, and the time you find out that there's a problem and you get it fixed. So good. We have some interesting responses here. Let me show you what everybody's clicking on. So nobody here is completely confident. I think I get that, right? It is one of those things that, again, it's scary. Things can move really quickly, and with infrastructure in general, right? Especially if you don't know what to check and you're not checking it in an automated fashion, you're not doing it before you deploy. You may not be able to catch those things in less than a day. We see a number of people that have an opportunity for improvement here as well, and again, that's not uncommon either. In our survey, we saw some very similar sort of results, right? We sort of grouped our respondents based on their responses to some of these other questions into really sort of three categories, right? So we have the folks who are doing fully automated checks all the time. We had folks who are doing some automated checks and some traditional sort of post-deployment checks, but they're not fully to that automated state yet. We have folks that they're really not doing any automated testing. It's all manual, it's all post-deployment. And you can see the ability to fix an issue in under a day, and how often folks are fixing an issue in under a day drops dramatically. If you go from automated to partially automated to not automated at all. And so I think it points to the fact that obviously, people want to do more of this testing. They want to get it in their pipelines. They want to have things even before the pipeline stage. They want to have it in their developers' hands, whether that's a developer that's an application developer or a developer that's an infrastructure engineer or some other sort of part-time-ish developer. They want to get these tools into their hands even before they commit code, right? So that they can see things as they're creating that infrastructure as code and then have it in their pipelines. So I mentioned earlier too, one of the questions we asked is, do you think you're using infrastructure as code to the best of current industry standards? And that included using all these different security tools. And only 7% of our respondents, again, there were over 500 respondents from a mix of company sizes, a mix of industries, and a mix of personas as well. Only 7% of our respondents would say that they are implementing IAC to the best of industry standards. So if you're in that other 93%, you're not alone. It's certainly, as I said, it's an evolving area. It's an area where I think a lot of people are looking for what to do and how to do it. In the last couple of minutes here, I'll just put in a couple of things about Snyk in sort of how Snyk does this. And I mean Snyk at Snyk, so our own infrastructure in application and AppSec teams and how they use infrastructure as code. And then I'll show you real quick to Snyk infrastructure as code, which is the product we have, which can help. But here's what Snyk does, right? We have a blog about this. If you want to read it, the link is here at the bottom. You'll find it on the Snyk blog. If you just search for Snyk at Snyk in our blog, you'll find it pretty quickly as well. But there's really sort of three keys if you read through that blog and read through what we're doing. The first is that we don't want to have any magic or mysteries, right? So we have criteria. Those criteria are published. Everybody can read them. Everybody knows what they are. And then once that's done, we require everybody to adhere to that criteria. Now, how do we enforce that everyone adheres to that criteria? That's another challenge. That's what gets into some of these additional key points here. The second one is no silos. That means, security can't just go off by themselves and write up the requirements and publish them and say, okay, everybody else, you have to follow these. We actively invite everybody who's a developer, everybody who is deploying things to Kubernetes, everybody who's creating some sort of infrastructure as code configurations, and we have them contribute their own ideas, their own feedback into these policies. And then all of the developers, security engineers, everybody who's involved in this, and that kind of goes back to this idea that it is a shared responsibility, right? They all have to document violations, notify our AppSec teams when those are occurring, and make sure that everything is done correctly, or if it's not, that there's a auditable trace for why that's not being done. And then the final thing, in terms of how we actually enforce and make sure that everybody is actually adhering to the criteria, is to make it ridiculously easy. At Snyk, we have one of our core values is being ridiculously easy to work with, and we want even in between our AppSec teams and our developer teams, we want this to ring true. And so we automate everything. We make sure that once all these criteria are established and published, that we can automate how we check those things, that we make it very obvious to folks, as they're creating this, infrastructure as code, or they're creating applications and deploying them, that they are going to be tested, that they'll get results of those tests, and that they'll know how to fix those as well. It's one thing to test this and alert that things are broken, but then you also want to actually help people be able to fix them. And that's a big thing as well. Not everybody is a security expert. Not everybody is a Kubernetes expert. Not very many people, I would say, are Kubernetes experts. And that can apply to other types of infrastructure as code as well, Terraform and other things. Certainly have all of their sort of intricacies in terms of how they're used. And so we really want people to be able to use all of those tools, right? So, if you're only testing after deployment, then you have a tendency to end up with lots of magic and mysteries. You're telling people after things are live that something's broken. And it gets hard with infrastructure as code to link that back to the actual code that created it, and actually go about fixing things. You also tend to get more silos that way. And if your engineers, the people who are writing this, whether that's infrastructure engineers or our application engineers or developers, right? If they don't know what to do as they're creating the code, you especially tend to end up with lots of silos. And it certainly is not ridiculously easy if people can't actually test things in some way, shape, or form, and preferably in an automated fashion. And so we want to have these things permeate throughout infrastructure as code usage, throughout the pipelines, throughout that life cycle for the infrastructure as code. And that's exactly what Snyk infrastructure as code can help with. And so this is my shameless plug here at the end of the webinar. Snyk infrastructure as code is available for folks if you want to test your own infrastructure as code. We support Terraform and Kubernetes formats today. You can get a free Snyk account and start testing infrastructure as code and use it to test both of those things. You can import, if you have your infrastructure as code, hopefully you have your infrastructure as code sitting in a Git repo of some sort. You can certainly import it that way. If it's just sitting on your desktop and you want to play around with it, you can test via our CLI tool. Our CLI tool can be used in CI pipelines as well. If you use GitHub and use GitHub Actions and in GitHub security, we integrate with that. So really, no matter where you want to test this and play around with it, you certainly can. The other thing about it is trying to make all this information as consumable as possible for that end user. Again, realizing that not everybody is an infrastructure or security expert. And so not only do we sort of point out where things can be improved and can be fixed in your infrastructure as code, we actually provide advice on how to fix it. So we'll give you things like exactly, the line number in the code that where you can add the security details that you need, but also provide information about the impact of those changes. What is the impact of this particular misconfiguration? What could happen because of it, and how do you go about fixing it? So that's all part of the Snyk infrastructure as code tool. And again, works throughout your development lifecycle. And the development lifecycle can change and vary depending on the infrastructure as code tool. How you use and deploy with Kubernetes is probably very different from how you use and deploy and would automate something like Terraform. Terraform has its own sort of unique steps. It still sort of fits into the general model, right? There's code. It sits in, hopefully sits in some sort of source code management system. You can, create it locally, and you can still run it through various automated tests. But they have their own ways of doing that, right? So you have Terraform plan, and you have Terraform apply. Snyk infrastructure as code is designed to fit into all of those workflows. So if you're using Terraform, using things like a Terraform plan, you can scan the plan. Or if you want to scan the files as you're creating them, you can do that, whether that's on your local system or scanning them in your source code management. And then when it comes to the running application, Snyk overall can help there too. So we can actually show you some details about the running applications. We can show you where, some of that configuration may actually make some of the vulnerabilities that Snyk detects via things like Snyk Container and other tools, where those misconfiguration issues might make those vulnerabilities a higher risk to your organization as well. So a number of places where we actually link in that infrastructure as code, that configuration, with results from other parts of Snyk. So that's the end of my presentation for today. I appreciate everybody joining us. If you're at Kubecon, I hope you enjoy the rest of the show. If you're not at Kubecon, have a great week. If you want to, again, as I said before, if you want to test out Snyk infrastructure as code or any part of Snyk, you can do that you can always do that for free. So sign up for Snyk if you don't already have an account. You can get the infrastructure as code for free and start using it. There's no restrictions on that capability. If you want to get a demo, get more information, we'd be more than happy to chat with you. If you want to see the Snyk infrastructure as code security insights report, that's available to you from the Snyk website, as is our new state of cloud native application security report. We'll also send up a follow-up for folks who attended today if you want to watch this again, or you want links to some of these resources. But again, I appreciate everybody. I appreciate you participating in the polls as well. Always really helpful and really interesting to see how people are doing things. But other than that, I'll wrap things up. Thanks everybody, and have a great rest of your day.